Why does NAT make packet forwarding complex? Imagine sending a letter through the mail. Normally, you just write the address and drop it in the box. But with Network Address Translation, or NAT, it's like the mailman has to change the address and keep track of every letter he delivers. That's what makes packet forwarding more complicated. In the internet world, devices send data in small chunks called packets. These packets have headers that tell where they are coming from and where they are going. When a device inside a private network wants to talk to the internet, NAT steps in. It changes the private IP address, which is like a home address only visible inside the network, into a public IP address that everyone on the internet can see. It also changes the port number, which helps identify different conversations happening at the same time. This process requires the NAT device to keep a list, called a translation table. Every time a device inside the network sends data out, the NAT device records the private IP and port and replaces them with its own public IP and a unique port number. When a response comes back, the NAT device looks up this table to find out which device inside the network the data belongs to. It then rewrites the packet's header to send it to the correct device. Because of this, NAT has to do more than just forward packets based on IP addresses. It has to look into the transport layer, which includes port numbers, and change those as well. This adds extra steps and processing power to the router or NAT device. It needs to remember all active connections, which takes up memory and CPU resources. If the NAT device is busy or has too many connections, it can slow down the network or cause delays. NAT also makes routing trickier. Normally, routers just look at the IP addresses to decide where to send data. But with NAT, the original source IP address is hidden or changed. This can cause problems for certain protocols that relying on knowing the real IP address inside the data. Some protocols might not work well because they embed IP addresses in the data payload, and NAT doesn't change those inside the message. Large networks like internet service providers use something called carrier-grade network address translation. This means many users share a few public IP addresses. Managing all these translations requires even more processing power and careful handling to keep everything running smoothly. In the big picture, NAT helps save IP addresses and allows private networks to connect to the internet. But it also adds layers of complexity to how data moves from one device to another. It requires devices to parse and rewrite headers, keep track of many connections, and handle special cases where protocols don't work well with address changes. So, NAT makes packet forwarding complex because it involves rewriting both the IP and port headers, maintaining a detailed connection table, and managing the extra processing load. All these steps are necessary to keep the internet working smoothly while sharing limited IP addresses.